Hey guys, welcome to the Sang for Robotics beginner course. This is your first lesson, which is the Intro into Robotics. So who are we from Sang? So we are high school volunteers from the computers of the next generation, which is Sang. And our mission is to inspire underrepresented students to develop an interest in computer science. Okay, so my name is Karthik, and I'm teaching robotics for beginners. And a fun fact about me is that I really like cars. Okay, so hopefully you guys will be able to join the Zoom next class. And before you do, I'd like to go over a few rules. Okay, so the first one is that you need to always respect your instructors and classmates. The second is that when you join, you need to put your first and your last name in the profile. Third is when you're in the Zoom, you always have to turn on your camera. And fourth is when you're in the Zoom, you can't do any side chatting with your friends, and please focus on the task assigned by the instructor. Okay, so for our schedule today, we're gonna just talk about like beginner robotics. Then we're gonna talk about this. Yeah, we're just gonna talk about beginner robotics today. Okay, so first we're gonna learn what robotics actually is. Then we're gonna learn the history of robotics. Then we're gonna talk a little bit about VEX Code VR, and then you're gonna do a quick activity in VEX Code. Okay, so right now I would like you to come up with a working definition of what you think robotics is. So you can pause here and try to think of it. You can also write it down if it helps you. Okay, so the definition of robotics is the branch of technology that deals with the design, construction, operation, and application of robots. So what do you think about this? How did it compare to your original definition? So you can pause here and think about that. Okay, so now I'm just going to go over quickly the history of robotics. So now I want you to think to yourself again, when do you think robotics started? You can write this down if you want. And actually, it started in ancient Greece, and it might surprise you, but the earliest form of robotics we have seen and witnessed was in 300 BCE. And this was the automata, and the ancient Greeks created this device, and it was used to perform automated tasks and harness the power of wind, water, and weights. And the earliest forms of these were seen in the 3rd century BC and were attributed to Ctesibius. So then we had robots that were in the Renaissance, and these were more complex than the ones in ancient Greece, but they are more simpler than the ones we have today. Unlike the robots we have today, they don't rely on code like we do now, and in fact, they don't even have electronics. So an example of this is of one of those robots was Da Vinci's Robot Knight, and it was designed in 1495, and it's the first example, one of the first examples of a human-like robot, and it was powered entirely by mechanical parts such as gears, pulleys, and cables, and like I said, had no electricity. It was designed to move its arms, legs, and head based on Leonardo's studies of the human anatomy, and this design shows that the core ideas behind robotics existed centuries before modern computers. Just a quick video we're going to watch.
Leonardo's mechanical knight could do more than just open its helmet. The knight was able to stand up, move his arms, turn his head, and sit back down again. Some sources also claim the knight may have produced an automated drum roll. The secret was in its construction. Leonardo's knight was built from wood, leather, and metal, and powered by a clever system of pulleys and cables. Movements of different limbs were linked together. When one arm moved up, the other moved down. But what inspired Leonardo to create the mechanical knight? The answer is quite sinister.
Okay. So
This is moving.
We're going to talk about industrial and computer age robots in the 1900s. And this is when robots started to gain electricity. And the industrialization, which was also in the 1900s, led to the creation of many factories and the widespread use of assembly lines. And basically, they relied on human workers, but the work was often repetitive and dangerous. But to improve safety and efficiency, the industrial robots took over what the workers used to do. And as these robots became more complex, programming became an essential part of robotics. This is a quick video we're going to watch about it as well.
Return. Leslie Mitchell reporting. A robot for industry. And this is it. Unimate, a machine that can reach out to 7 feet and perform a multitude of tasks in factory or laboratory as skillfully as a man, but without getting tired. It's controlled by a built-in memory system. You just lead it once through the required motions, and it can then repeat them 24 hours a day, week after week. It can position objects to within 50 thousandths of an inch. Completely unaffected by heat, cold, fumes, or dust, it could take over a lot of unpleasant jobs. It can operate unattended for 500 hours. Originally developed in the States, it's now being made in Britain, and this was its public debut. Have one with me. The largest helicopter in the world.
Okay, so yeah, that's a pretty interesting robot. If you could right now, I'd want you to think about how the robots have changed from then to now, and how they have maybe improved, or how have they stayed the same. Okay, cool. So now we're gonna talk about modern day robotics. So modern day robotics uses sensors, computers, and code to interact with the interact with the real world and further help humanity. And right now, electricity is paramount in robotics. You cannot have robotics without electricity. And some examples of modern day robotics include the Perseverance rover exploring Mars and surgical robots decreasing the workload for doctors. Okay, so now I want you guys to think what you learned in this lesson. If you want, you can write down something you found interesting and something cool that you learned. Okay, and now you can pause and take a 5-minute break. All right, so now that you're back, we'll talk about VexCode VR. So VexCode VR is an online coding platform that we use to control a virtual robot, and it runs in your web browser, meaning you don't need to download anything, and it uses block-based code to instruct the robot, and the robot can move, turn, and complete tasks, and this lets us practice robotics safely and easily without having physical robots. It'll be like the main app that we use in this course. Okay, so this is a quick video we're going to watch about the basics of VexCode VR.
What's up, everyone? My name is Om, and I'm the lead for the Sang Robotics team. In this video, I'm going to show you the absolute basics of using VexCode VR with block coding. So if you've never used it before, this will get you started really quickly. When you first open VexCode VR, the first thing you want to do is choose a playground. You can click on the Playgrounds button at the top right, and you'll see a list of different environments. Each playground is designed to practice a specific skill, so for now, we can pick a simple one, and later you will be instructed to pick a specific playground for your task. Once the playground loads, you'll see 3 main parts of your entire screen. On the left are all of our coding blocks, in the middle is our workspace, and on the right is a robot inside the playground. The playground can be moved around as a separate window, but I would recommend keeping it in the top right for now. To make the robot do something, you have to drag a block from the block menu, just as you would do in Scratch. The blocks snap together like puzzle pieces, and they run from top to bottom. When you're ready to test your code, press the start button in the playground, and your bot will begin doing its task. To stop it, just press it again. And to restart, click the restart button. Some more things you should know are how to save your files. Click on the File button at the top left, and then Save. If you have any more questions on how to use VexCode VR, please ask your teacher and they'll be able to help you out. Thank you, everyone, and enjoy the robotics session.
Okay, so now we want you to use VexCode for your own mini project. Okay, so what we want you to do is to create a rainbow exclamation mark. So first thing you guys can do is to log into VexCode VR. So pause here, log in, and come back when you're done. Okay, so then you're gonna open a project and select the playground grid map. And then you're gonna use the drivetrain and drawing code sections to create an exclamation mark in the center of the grid with different colors in each square. So you can pause now and try that. And this is the answer for the code, but I highly encourage you to try it before. Try it yourself. And this is a demo of what it looks like. Alright, so that's going to be it for today's class. If you guys had anything you're confused with, please come to office hours. Office hours are on Tuesdays and Sundays at 4:15 to 5:15 p.m. I or another one of the robotics teachers will be there. So, yeah. So thank you guys for coming. I hope you guys had fun and join us again.